Okay, I'll get you one. Here we go.
I just didn't want to point her out.
Okay. Here we go. Now, the page you're looking at is all laying the groundwork. Before I go to your notes, you guys have to have some background knowledge. Here it comes. The first word I put on there is polynomial. Okay? I'm just trying to tell you what a polynomial is. A polynomial is just one term or more. One term or more. Now, a term looks like this. X to some power. I'm going to call it n. Then there's always a coefficient in front. I'm going to call it a. So like 2x to the third, like that. Then followed by the next term. There's a coefficient, x to the n minus 1, which just means this exponent, if it's 5, this one's what? 4. Okay. Plus a times x to the n minus 2 plus, until you get to what?
A.
Just the a, followed by x to the what? 0, which means there's no x term. There's no x. So this is just a number like plus 7, plus 12. That's all it is. Here's a quick example of what I'm saying. Ax to the n could have been 3x to the third. You should write this down. This is your example, 3x to the third. Plus another coefficient like 7. X to the
Second.
yeah, because really this 3 is right there. This 3 goes here. 3 minus 1 is 2. Plus 5, x to the what?
1,
Yeah, because 3 would go here, wouldn't it?
but then there wouldn't be 1.
Well, there'd be
Yeah,
a
there would be
x to
no.
the first, right? Isn't 3
Well, yes, but
minus 2, 1?
You wouldn't need.
Right.
you wouldn't have to
One.
actually put down 1. Because
Oh, yeah, I don't have to put 1. Yeah, you're right.
Are they always systematic like this?
Yes, and see, that's what
There will always be like a 3 or a 2 or a 1.
3, 2, 1, none. 3 or 4, 3,
Yeah.
2, 1.
So it won't be like 4 and then like there's like 1x.
Oh, it could be, yes. There could be nothing here.
Okay.
Like this whole term could be gone. This whole term could be gone. And then it could
Okay.
just be a number. And then 10. I'm just throwing a 10. Just for whatever. Good? That's what a polynomial looks like. Have you ever seen something like that?
yeah.
Yeah, of course you have. Okay. So then what is this? The next word says what? Standard form. Now if you read it, just read it, it says, I can't remember how to word this. It says the polynomial is written with the highest degree term first, followed by the next highest degree term, followed by the next, followed
So
by the next.
basically, what we just.
So basically what we just did, right? So let me just give you one that's not in standard form. How about this? 7m plus 8m squared. Is that in standard form?
No.
If you read the definition, you'd say what? Not in standard form. Why not? What's supposed to be first?
The highest.
Highest power of your variable. M what? Squared?
Yes.
Okay. So to put it in standard form, you would have to say what? 8m squared plus 7m, and now it is in standard form. Okay? There you go. Good? What's next? Term. Okay? And a term is
Number.
a variable. Oh, that's all it is? It's just a variable. A term is a variable.
No.
There. How about the letter K? So a term is a variable or
Number.
a number. 6. Or
Or the product of a variable and a number.
the product. What does product mean?
Like addition.
No.
Almost.
Multiplication,
X.
yes. So I'm telling you, a term is a variable, or it's a number, or
I'm not wrong.
multiplication. How about 6K? So 6K is a term. 6 is a term. K is a term. But to be honest, what is a term? It's just multiplication. If you see multiply, it's a term. So where's the multiplication here and here? Times 1 here. Where is it here? Times 1. 1 times 6, 1 times K. If you have multiplication, you have a term. So here's kind of a wicked looking term. What if I give you 8KP? Is that a term?
Yes.
Because
Multiplication.
you have multiplication going on here, here. Okay. What if I would have done this? 8KP plus L.
Only 8 kp is a term.
8KP
And then
is a
L,
term.
and then L is
L is
a
a
term.
term. 1L. You have how many terms?
2.
2
Trinomial.
terms. 2 terms, and the reason you have 2 terms is because what separates terms? A plus sign or a minus sign.
What
So,
about division?
okay, let me try that. Hang on. Would you guys agree that's still 2 terms?
Yes.
Okay. Then you said what? What about-
I said division.
Oh, you said division. Okay, watch this. 8KP divided by 3. Does that separate terms?
Well, isn't it still 2 terms though?
No,
Because-
see what it is? You still have multiplication going on. Here's what you have. You have 8/3 times K times P. The way I wrote it, I didn't quite write it like that for a reason. I wanted to kind of throw it off a little bit. But this is still multiplication, isn't it? So when you said division separates terms, no, it doesn't.
Okay.
Because 8 divided by 3 is 8/3 times KP. What separates terms? Pluses
Minus.
and minuses, okay? So what are the next 3 things telling you?
Monomial, binomial, trinomial.
Hey,
So one
you guys,
term.
I've been using those words at you all year. Monomial is 1 term. Binomial is 2. Trinomial is 3. Okay, so let's throw some quick examples down. What's a monomial? Anybody want to just throw one up?
8x.
1 term.
8x, okay? And then what's a binomial?
8x plus 6.
8x plus 6. Or negative 10x minus 12. You know, something like that. What's a trinomial? 3 terms.
Which would be like
7x minus 3 plus 4t.
Plus what?
4t.
4t. Okay. Got it. Whoops. Got it. We're all good. Yes? With that background knowledge, we can start your notes and we can fly. Here we go. Here it is. If I didn't do what I just did with you, you'd be wondering where I'm getting all this information from. Okay, step 1, or problem 1 says write S if the expression is in standard form. Write N if it's not in standard form. S or N. Okay, take a look and do it quick. All right, first problem, Molly, yes or no?
No.
She says, no, it's not in standard form. If it was, Molly, can you give it to me?
Yeah. Negative 13x squared plus 7x plus 5.
Yeah, and that would be it. If it was in standard form, that's what it would have looked like, okay? You might want to write that down just so you know. Okay, the second one, Adrian, yes or no?
Yes.
He says, yes, it's in standard. Do you guys agree? Yeah? Say something if you don't,
Yes.
because it is. He's right. Okay, last one, Taylor, yes or no? Mm-hmm. He says, mm-hmm. Agree or disagree?
Agree.
Agree. M to the second, followed by M to the first. It looks good to me. Standard form is just highest power of x, next highest, until you get to 0, a number. Okay, then they talk about polynomials, and they describe their polynomials differently than me, so let's just not worry about this. All they're saying is a polynomial is made up of a bunch of what?
Monomials.
Monomials. If you add or subtract them, you get a polynomial. That's all they said. Then they talked a little bit here about mono, bi, and tri. Okay, but they didn't say anything. So let's just keep moving. These three problems, they want you to do this. Write the number of terms in each polynomial. So just count. Are there 6 terms? 2 terms? Whatever. Okay, this should take you 10 seconds. Colby, where are you going to put it?
Right there.
It's there? Okay. Is that the graphing method quiz? That was the graphing method quiz, right?
It's the solving system by graph.
Got it. Good. Okay. Tyler, how many terms? How many terms do you count? 3. He says 3. Do you agree with him?
Yes.
Yeah.
6 is a term. Minus 7x squared is a term. Plus 3x is a term. What separates terms?
Subtraction.
Plus or minus? Yeah, 3 is the answer. The middle one. Gavin, what's the answer?
5.
5. Do you agree?
Yeah.
Yeah, I'm not going to circle. Last one. Aaron, what's the answer? He says 4. Is he right?
Mm-hmm.
That is a term. I know it's really long, but it's all multiplication. So is this, so is that, and so is 7. There's 4. Okay. So what do we do today? Today we look at polynomials. Right here. We're going to look at polynomials, and we're going to classify them. Classify them by degree and by number of terms. Which one seems easiest? Number of terms. All you got to do is count. It's so simple.
Why?
Just count. Okay, so they were so nice to you, they actually counted for you. Guys, 5 is 1 term. What do we call it?
Monomial.
Monomial. Monomial, binomial, trinomial. Those are your choices. So you'd say monomial. Okay, the next one, they counted for you. This is, I don't know why they did that for you, but they did. 2 terms is called what? Binomial, followed by another 1-termer. Say it.
Monomial.
Monomial. And then all of a sudden it's a long one, 3 terms. Trinomial, okay, followed by a shorter one,
Binomial.
2 terms. Binomial. Okay, and now here comes a wicked one. They give you this. How many terms? 4 terms.
Polynomial.
What'd you call it?
Polynomial.
Okay, here's the deal. After 3, there's no more special names. We go back to the generic name. The generic name is
Polynomial.
polynomial. What's a polynomial? 1 term or more. But when you say 1, there's a special name. Monomial. 2, bi, 3, tri. After you get past 3, you just call it polynomial.
I feel like
You have.
Did it
Hang on. You gotta tell me. Of how many terms?
4.
4. You have
Oh,
to.
you gotta say that.
Yeah,
4.
you gotta say it. Because really, I'm just asking you to do one thing. Count. Just count the terms. I want to know, how many terms did you count? 4. That was the easy side. This side is not so easy. But, you know, Harry says, I feel like I've done this before. You did it in 9th grade. This stuff has all been taught to you in 9th grade. Okay, classify by degree. Now, by degree, you look at the highest power of your variable. What's the exponent
Row.
behind the 5?
1.
Yeah, it's x to, whoa, it's not 1.
No, 0.
It's x to the
There's no
0. When you have x to the 0, it means you have no x's. So what do we call this? There's a name for a number.
Number.
It's a number. There's a name for a number. What kind of polynomial is that called? Oh, you guys forgot?
coefficient.
No?
Constant.
It's a constant. It is a polynomial that will never change. 5 will always be 5. You can't change 5 if it doesn't have a variable behind it. Okay, so now, this is what you did in August, September, October. X to the first. Think of the graph. Think of the graph. It's linear. Yeah, it's linear. Every time you have to think of the graph. When you see x squared,
Quadratic.
no, that is, the graph is a parabola,
Quadratic.
but it's called a, what kind of
Quadratic.
quadratic? This is what you did in chapter 4. Chapter 4, all you did was quadratics. Okay. All right. If you see an x cubed, though, it's known as a
Cube.
cubic. It's cubic. X cubed is a cubic function. Then you see x to the 4th.
Well, I don't know.
That's not quadratic. That's x squared.
Yeah.
Okay? Nobody? Looks like quad, but it's not. It's quart. Oh, you guys, ninth grade. Your ninth grade teacher might be a little upset right now. It's called quartic. Okay, here's the deal. When you see 4, I think of 4 quarters makes $1. 4 quarters makes $1. Well, if I see a 4th degree, it's quartic. Quartic. 4 quarters in $1. Okay, 5. X to the 5th. It's another cube. Ooh, quintic. Yes. It's quintic. It's quintic. X to the 5th. X to the 6th. X to the 7th. If I knew the name, I'd tell you, but I don't. Okay.
I swear if they start with Q's, I'm gonna throw something.
3 of them are Q's though. Q, Q, Q. Careful.
Yeah.
Okay.
Yeah.
All right, next. This is what your assignment looks like right here. Classify your polynomial. How? Write each polynomial in what form? Standard. That's the first thing you do. Then do what? Classify it by what? By degree and by what? Number of terms. There you go. All right, I'll turn you loose for like 20 seconds. Try A. Twenty seconds are up.
Okay.
That was a long 20 seconds, by the way. In standard form, Harry, can you give it to me?
By x to the 4th
Okay.
plus 3x to the 3rd.
Okay.
Minus x.
And then minus x. Harry, can you give me the degree? It's what?
Quartet.
Quartic. Okay, right here. I hope he's looking right here, isn't he?
Yeah.
It's quartic. Harry, how many terms were there?
3.
3. What's that called? Trinomial. Oh, there you go. First one's done. That's it. Hey, that's 3 points on the test or quiz or whatever. That's a lot. You don't know your names, you're going to get so mad at yourself. Because this is not hard. It shouldn't be hard. Standard form. Eric, can you give it to me?
What was the first one?
Yep. No, or B.
6x cubed minus 2x.
Okay. Followed by degree.
Binomial.
No, you actually went here.
Oh, cubic.
Okay, he looks here. He said calls it cubic. Is he right?
Yeah.
Yeah, he's right. Okay. So cubic because of x cubed, and 2 terms because he sees a term minus a term. Faith, can you give me this one?
Negative 4x
4x to the 5th.
plus 2x to the second.
Okay.
Plus 3x
Plus 3x what?
plus 10.
Plus 10. Agree? Yeah?
Yes.
When to put negative.
Yeah, see, if you forgot your negative, you're going to get a little bit off on the test. Okay, next. By degree, Faith?
Quintic.
Quintic. She says quintic because she sees the 5. A number of terms?
Polynomial.
Yeah, there's no special name. It's polynomial of
4.
4 terms.
4 terms. Okay. Gotcha. There you go. I think we're catching on to this. Gavin, what's this one going to be? Standard form.
-7.
Not much to do in that one. You're done.
Constant.
Constant. What else?
Monomial.
Monomial. Okay. Got it? Okay, last one. Branson, what do you think?
6x squared minus 4x minus 8.
Okay.
That would be quadratic.
Okay, he looks at the 2, says that's quadratic. He's right.
Trinomial.
Trinomial. Yes or no?
Yes.
Yes. 1 term minus 1 term minus another term. That's 3 terms. It is tri, and it's nomial. Nomial means term. Tri means 3. Good.
Yeah.
First page done.
Yeah.
It's nothing but words. There's very little math today. You're probably going to like this assignment. It's pretty simple.
What?
Just got to use a lot of names.
This is math class.
Okay, here we go. Okay, now,
Whoa,
this next page is going to talk about a polynomial graph. How does a polynomial graph look? Okay, let me just do some things with you. Ready? Before I get into that page, watch this. Polynomials, if it's linear, guess what? Linear is what? A line. There's not much to it. It's straight, it's smooth, it's nice, it's easy. But parabolas, which are quadratics, they get, used. I can do this, right? Okay, but once you get past x squared, then they get crazy. Watch this. An x cubed might go like this, or an x cubed might go like this. And believe it or not, you will be graphing all this stuff in just another day or 2.
No.
Okay, what does an x to the 4th look like? A quartic? It could look like a parabola, or it could look like this. Or maybe even this, who knows? But one thing I want you to know, they're very smooth. Would you agree?
Mm-hmm.
They're smooth, they're not jagged, so you will not ever graph this. You're not going to do that, because this is not what a polynomial looks like. They're not sharp. What's sharp? What kind of function is sharp?
A linear.
No.
Absolute.
Oh, somebody said it.
The absolute value.
Absolute values are sharp, they're V's. V's are sharp. Absolute values are not polynomials, okay? What else should you notice? Hey, you should notice this. On the left, what does your polynomial do?
Down.
On your right, what does it do?
Up.
Or maybe in this case, it goes what? Up, up.
Down,
So
down.
here's the thing. You have to tell me what your polynomial does this on this side and on this side. Okay. Now let's go back to your notes. I think you have enough information. Ready? The degree of a polynomial function. And by the way, the degree would be linear, quadratic, cubic, quartic, quintic. The degree of a polynomial function affects the shape of its graph and determines the maximum number of...
Curves.
Ooh, close, not curves.
Well.
Turning points.
Essentially.
So the degree will tell you how many times your polynomial will turn. Okay? Now, question. You know what a turn is?
Mm-hmm.
Yes, this is the game.
It turns. So is this a turn?
It's like, yes.
Okay, wait. Whoa. Wait a minute. Taylor said I'm turning. Taylor says, I'm turning. Am I?
I mean, yeah.
No,
You're
Oh, is
curving.
that where?
I'm not turning yet. When am I turning? When I start to what?
Go down.
Go down. See, the whole time I was going up, 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 up. I'm not going up very fast anymore, but I'm still going up. Until I go what?
Down.
Backwards.
Down. Now it's a what?
Turn.
It's a turn. This is not a turn. This is not a turn. I'm going up, 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 down. The second you reach the what? The highest point. Once you start saying up, 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 down, now you turn. Okay, that's what a turn is. We'll talk about it tomorrow. Okay? So, what is the other thing they wanted you to know? Here it says the graph changes direction. That's what a turn is. It also affects this is what you and I are talking about. The
Width.
what?
I said width.
No. No, remember when I circled those things?
Width.
End behavior.
The end behavior. The end behavior is what it does in the end of the graph. Does it go up, up, down, down, up, down, or down, up? See, there's 4 things that your polynomial could do. It's right here. You could go up, up, down, down. This one is down on the left, up on the right, or up on the left, down on the right. How are you going to know what your what your polynomial does? Read this right here. You can determine the end behavior of a polynomial function of degree n from the leading term. What's the leading term?
One that has the largest.
On the front.
The one in the front. If it's in standard form, it's the one in the front. What does it look like? Ax to the n of standard form. Here's a little table that tells you what it does. I don't like this table because it's too wordy. So I'm going to draw you a quick picture. You can read that, or you can draw the picture next to it. Here it goes. What they're telling you is this. Okay, if you have an even function versus a what?
Odd.
Odd. You might want to write an example of even. X to the second, X to the fourth, X to the sixth, okay? That's what they're talking about. Or if you have odd, X to the first, X to the third, X to the fifth. That's what odd and even are when it comes to functions. Okay. If your leading coefficient in front, remember this is what it looks like? Okay, so if A is positive or if A is negative, this will tell you everything about your graph. All right, ready? Even functions act like parabolas. This, or this. When's it going to go up, up? When the leading coefficient is positive or negative?
Negative. Positive.
Positive means it goes up, up. So this is an up, up. That's what it says to you, but I just feel like there's too many words. This one, what if your A value is negative?
Down, down.
Then it's down, down. Okay, so what kind of polynomials act like parabolas?
The even.
Even polynomials act like parabolas. Up, up, down, down. What you guys don't know is this. You don't know this.
How
Does it do this, this, this? What's it do? I mean, you have no clue what it does, but you do know the end behavior. Okay, what do odd functions act like? Not parabolas,
The lines.
lines. They act like lines. A line going up or a line going down? Okay, when's it going to act like a line going up?
Positive.
When the A value is positive. Think positive slope.
Okay.
So it's going to be what?
Down, up.
Down on the left, up on the right, and again, we have no clue what it does in between. No clue. We'll figure that one out tomorrow. What about an odd function that has a leading coefficient that's negative? That acts like a line,
No.
A line
not
going down.
that simple.
up, down, up,
Especially if we do it.
down. Again, you have no clue what it does in the middle. Are you okay?
Yeah.
Maybe this picture helps you more than reading all the words. The word, and this says the same thing I just wrote. It just not too much. Okay, here comes your last part of your assignment. Determine the what?
And behavior.
The end behavior of the graph of each polynomial function. You got 4 of them. Take a look. See what you think. Okay, I don't want you to sit there and do nothing, so please listen. When I ask you to look at this polynomial, ignore everything except what?
The degree.
The leading the leading term. The leading term is,
Oh, so you're
that's all you're looking at, guys. You're just looking at negative 4x cubed. Tell me, what degree is this? Even or odd?
Odd.
Odd. Tell me the LC. The LC is the leading coefficient. Is it positive or negative?
Positive.
It's negative.
Oh,
Negative.
okay. Okay.
So guys, here's what you have. An odd function. An odd function acts like a line this way or a line this way. Because your leading coefficient is negative, you're going to say a line that goes
Up and down.
downhill. I think of slope. Negative slope goes downhill. Positive slope goes uphill. Okay? So you got this look, don't you? Up on the left, down on the right. Up on the left, down on the right. What you don't know anything about the middle. And you will learn tomorrow that there is a middle.
Great.
Okay. Finish it. Just finish it. Just so you know, you didn't even have to look at anything past the leading term. Okay. Travis, degree of this one is what? Even and leading coefficient?
Down.
No.
Oh,
I meant positive or negative.
that would be negative.
Negative. So even acts like this or this.
Down.
He already said it. Down. Okay. Okay, that's it. Down on the left, down on the right, done. John, degree of this one is what? Odd or even? Odd. He says odd. Leading coefficient is positive or negative? Positive. You have a positive odd polynomial. Acts like a line. Which one? No, lines don't go down. They go
down. Up, down.
up, down. Positive means a line that goes uphill. You have this one. When you write positive, think positive slope. How does positive slope look? Uphill.
Down, up.
How does negative slope look?
Up, down.
Downhill. Okay? All right. Anyways, this is a line going where? Up. And you just don't know what's going on here in the middle. You don't know. It's just down, up. Next, Molly, finish it. What's this? Even or odd?
Odd. Same it.
Are you looking right here?
Yeah, because, you have to look at that. I
Yeah,
was looking at the wrong
the power of x is
Even.
even, gotcha. Then look here, the number in front is 1, so it's positive or negative?
Positive.
Positive. You have a positive even function.
Up,
This or this?
Up, up.
Up. Okay, you have an up? Up. We will figure this out tomorrow. We'll figure out the middle tomorrow, okay? That's all I got. That's it. You have a book assignment 285, page 285. If you're retaking the test, would you please let me know before you leave? Just want to get an idea of who's retaking.
I know. Oh, wow. I'm retaking.